Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm just going to go over an introduction to stoichiometry, talk to you a little bit about what stoichiometry is, and go over a couple of examples. So, what is stoichiometry? Stoichiometry is where you are going to be using a balanced chemical equation in order to help you convert from one substance in that balanced equation to a different substance in that balanced equation. And the key to all stoichiometry problems is going to be the mole ratio in your balanced equation. So, for stoichiometry, we're looking at making the amounts of reactants and or products that are involved in a reaction. So, you're dealing with questions like how much of this product is formed during the reaction if I start with this amount of reactant, right? So if I have a certain number of grams of A as a reactant, how much B product would I have, right? So the question is, how much am I going to have? How much do I need? Or how much will I make? And that could be in grams, it could be in liters, it could be in moles. So those are the type of questions we're asking in a stoichiometry problem. And so, like I said, we need to have a balanced equation before we can do any stoichiometry because the balanced equation gives us what is called our mole ratios. And that is the coefficients that are there in the balanced equation between the different substances. So, the coefficients in the balanced equation will give us insight into how much of each thing we need. So, here's a couple of examples. So in this equation here, where I'm reacting hydrogen plus oxygen to give water, I can see right away that in order to react two molecules of water, I need at least one molecule of oxygen. If I don't have at least one molecule of oxygen, I'm not going to react two molecules of hydrogen, right? So same thing with the product. So if I want to make two molecules of water, I need two molecules of hydrogen and one molecule of oxygen. So it's kind of like a recipe. So you could think of this in the same way of like making peanut butter and jelly sandwiches or making pizza or making a bicycle or something like that, where if you are like, let's say you're making a bicycle, you need one bicycle frame and you need two wheels, right? So if you're going to make one bike, you need two wheels, right? So if you only have one wheel, I'm sorry, you're not going to be able to make a bike, right? So there's certain things that you need in order to create the product that you are making. Like, so for example, peanut butter and jelly sandwich, I need two pieces of bread, right? Unless, of course, you're going to fold the bread in half, but we're not talking about that. We're talking about a nice traditional peanut butter jelly sandwich with two pieces of bread. So, in order to make one of those, you're going to need two pieces of bread for every sandwich you make, right? So, if you have 12 pieces of bread, you hypothetically could make six sandwiches. If you have 13 pieces of bread, you can only make six sandwiches because that 13th piece is not going to be used, right? So this is kind of like a recipe to make stuff. So not only can we think of the coefficients as molecules, right? Two molecules of hydrogen reacting with one molecule of oxygen to create two molecules of water, but we can think of these as moles too, because remember, a mole is just a number. A mole is Avogadro's number, 6.022 times 10 to the 23rd. That is a mole. So same as if I use the word dozen, right? So if I had 2 dozen molecules of hydrogen reacting with 1 dozen molecules of oxygen will give me 2 dozen molecules of water, right? So I'm just using the word dozen to represent a number 12, right? So 2 dozen is actually 24, right? So mole is just a number. It's 6.02 times 10 to the 23rd. So I can use the coefficients to talk about moles. So I can see, okay, well, 2 moles of hydrogen molecules will react with 1 mole of oxygen molecules to create 2 moles of water molecules. And the same thing with this equation here. So I have 2 moles of acetylene, or 2 molecules of acetylene, will react with 5 moles of oxygen to produce 2 moles of water and 4 moles of carbon dioxide. So I get these mole ratios from the coefficients. Don't change the coefficients. You don't need to simplify the coefficients if it's 2 to 2, right? So this ratio, the mole ratio between hydrogen here and water, is 2 to 2. Don't reduce it. Just use 2 to 2. Don't reduce it to 1 to 1. Okay. So same thing with here. So 2 moles of acetylene, 2 moles of oxygen, or I'm sorry, water. And so if you use that ratio to convert, you can keep the numbers at the way they are. Okay. And so when you're using those mole ratios, right? What I mean by mole ratio is you can use these mole ratios to as conversion factors. So if I wanted to convert from, say, moles of hydrogen to moles of water, or maybe moles of oxygen, I can use the mole ratio between those two substances to create a conversion factor. So let's say I want to convert a certain number of hydrogen to a certain amount of oxygen. Maybe it's moles, right? So let's say if I want to convert, let's say I have 3 moles of H2 and I want to convert that to oxygen, well, I can use a mole ratio as a conversion factor. So I have moles of hydrogen on top. I want to convert that to oxygen. Well, what's the mole ratio between hydrogen and oxygen? It's 2 to 1. So 2 moles of hydrogen needs 1 mole of oxygen. So I can just use the coefficients, put the 2 moles of hydrogen on the bottom, and I can take the 1 mole and put it on top. 1 mole of oxygen on top. Notice all I'm doing is I'm using the coefficients as numbers of moles. And so I get my mole ratio directly from the balanced equation. So now moles of hydrogen cancel out. Now I have moles of oxygen. So now I can calculate the number of moles of oxygen needed to react with 3 moles of hydrogen. And so that is using your mole ratio from the balanced equation to do stoichiometry. I'm converting one substance into a different substance in my equation. So I'm going from one reactant and I'm converting to another reactant to figure out, well, how much of this reactant do I need to react with this? And it's all about the mole ratio, from which I get my conversion factors to convert from one substance to another. So next, I'm going to go over a couple of example problems, and that'll be it for this video. So stay tuned. Okay, so let's go over a couple of examples. So here I have my balanced chemical equation. I've got the coefficients here, and so let's use the coefficients and see how we can use this balanced equation to convert from one substance to another using the mole ratio. So first problem we're given is how many moles of carbon dioxide can be made from 19.46 moles of oxygen gas. And so we got to figure out where we're starting and where we're going to go. So they're giving us 19.46 moles of oxygen gas. So we're given oxygen gas. What do they want? We want moles of carbon dioxide. So we need to convert the amount of oxygen gas we're given to the amount of carbon dioxide that is supposedly made from this amount of oxygen gas. So we set up our conversion factor problems, those normally the same way we do with dimensional analysis. So we're converting from one unit to the next. So we're going to start by writing 19.46. So 19.46 moles of oxygen, O2, put it over 1. And we're going to set up our conversion. So we want to go from moles of oxygen to moles of carbon dioxide. So the way we're going to do that is the mole ratio. The mole ratio allows us to go from moles of one substance to moles of a different substance using the coefficients. So we want to go from oxygen to carbon dioxide. So we're going to look at those. So the coefficient of oxygen is 5. That of carbon dioxide is 4. So that tells me that for every 5 moles of oxygen that is reacted, I produce 4 moles of carbon dioxide. So I'm going to use that to convert oxygen to carbon dioxide. So I'm going to put 5 moles of oxygen on the bottom and 4 moles of CO2 on top. And so you'll see that moles of oxygen cancel out. Now I'm left with moles of carbon dioxide. So I am done. So to get the moles of carbon dioxide, I just multiply 19.46 times 4, divide that by 5, and I get 15.57 moles. Let me double check. 57 moles of carbon dioxide. So this is the amount of carbon dioxide that would be produced from this many moles of oxygen. Okay, so that is the first example of how to use mole ratios from your balanced equation to convert from one substance to a different substance. What about example 2? Here, instead of giving us a reactant like last time, they're now giving us a product, water, and they're asking us how many moles of oxygen gas did you have to use or did you have to start with in order to produce this amount of water? So we're kind of going backwards a little bit. So they're giving us water and they want to know, well, how much oxygen was used up. So we're going to start with what we're given. So we're going to start with 13.42 moles of water. So H2O over 1. And then we're going to multiply by the conversion factor. And so they want us to go from moles of water to moles of oxygen. So water and oxygen is what we're looking at. So we want to look at the coefficients for water and oxygen. So here the coefficient is 2 for water and 5 for oxygen. So it's a 2 to 5 ratio, 2 moles to 5 moles. So I want moles of water on the bottom to cancel out with moles on top. So I have 2 moles of water on the bottom, and I have 5 moles of oxygen on top. And so moles of water cancel out. Now I have moles of oxygen, which is what they're asking, right? So how many moles of oxygen gas did you start with? So then all I have to do is multiply 13.42 times 5 divided by 2, and you get 33.55 moles of O2. So that is the amount of moles of oxygen needed to produce this amount of water. So I hope this was a good video. I hope this helped you understand stoichiometry, and I hope you found it interesting. Please let me know in the comments. If you like this video, then please, by all means, share this video with your friends. Hit that like button down there. Smash that like button. Also, make sure you subscribe to my channel. Hit that notification bell. When you hit the notification bell, please make sure that you hit the all so you can be notified by all the videos that I put out. And again, put a comment in the comment section. Let me know what you think. Ask me questions. I'd love to hear from you. Thanks for joining me and have a great day.